Periodic functions are functions that repeat in patterns. Again, we notice many things in nature that has repeated patterns. So imagine we have some function evaluated at t plus some period. And if that equals the function evaluated at t, then we have a periodic function. Sine and cosine, tangent, cotangents are periodic functions. Sine, as you know, if we find some value t and then we add a full revolution to it, we're right back to where we started. So sine, cosine have periods of 2 pi. They're periodic functions. Tangents and cotangents are also periodic, but their period repeats every pi units, not every 2 pi units. So how can we use that? Well, let's look at an example here. The cosine of 420, we know that cosine is a periodic function. It rotates or it gets back to where we're at every 2 pi. So we know that cosine of 420 is the same thing as the cosine of 360 plus 60. Can we say that? Which then equals just the cosine of 60. And then the cosine of 60, if we remember where that's at on our circle, the cosine of 60 is 1/2. And so knowing that the cosine is a periodic function, we can go ahead and remove a period from that, and then it helps us to evaluate it at 1/2. Another example that I want to look at is the sine of 9/4 or 9 pi fourths. And so we would say that is also a periodic function, which equals, looks like that's a 2 pi plus a 1/4 pi. That's 8/4 pi plus 1/4 pi gives me 9 pi, which means that then that equals the sine of 1/4 pi, or some people like to write it as the sine of pi fourths. And then we know that to be evaluated at √2/2. So it's useful to know periodic functions and when do they continue or start their rotation again. Cosine and sine, every 2 pi. Tangent and cotangent, every pi. So much so that we might be able to even take our original models here, and then what we would add then is we know that it revolves around every 2 pi, 4 pi, 6 pi, and so forth. And so we might include an n right there. So it's every multiple of 2 pi. And likewise for tangent and cotangent, every multiple of pi, n number of pi's around. So that's a little bit of how we can help understand what a periodic function is and what the application of it might be.